Karibu Ibrah Network Lab. Hii ni kozi kamili ya Cisco Certified Network Associate. Kupitia kozi hii utajifunza jinsi gani na namna network inavyofanya kazi. Okay, so today we are going to learn the Ethernet header. Ethernet header is in the Cisco exam guideline topic 2.0, which is switching and network access. Ethernet header is one among the very important topic to your CCNA exam. So by understanding the Ethernet header, you're going to be able to understand the fundamental function of the switch. So as we said before, the switch, they operate on layer 2 of the OSI model. And the device which operate on layer 2 of the OSI model, they use MAC address to forward the frame. So in this topic, we are going to cover in depth now, how does the switch use to learn MAC address, how it decides to forward the frame from the source to the destination. Okay, I'm hopeful those words are enough for the introduction. Let us begin. Okay, so this is the Ethernet header. Now, before kabla tujaanza kuichambua the Ethernet header, do you remember in the previous video ya OSI model in the part of the encapsulation process? And do you remember the PDU that is created by layer 2 of the OSI model, which is a frame? Now, in the encapsulation process OSI model, the PDU ambayo inakuwa created by layer 2 ya OSI model, it was a frame. Now, a frame is the PDU ambayo inakuwa created by layer 2 of the OSI model. Now, Ethernet header is a part of the Ethernet frame that is created by layer 2 of the OSI model. So without wasting time, nitaenda kuchambua Ethernet header. So huu ndo muonekano jinsi Ethernet header inavyoonekana. It contains the Ethernet header, the packet and the trailer. It's just the same as in the previous video ya OSI model. Inapofika PDU inapofika katika layer 2 ya OSI model, the layer 2 header pamoja na trailer inakuwa added and together they form the frame. Now, the Ethernet header as we said ni part ambayo inakuwa contained katika Ethernet frame ambayo inakuwa created katika layer 2 ya OSI model. Now, Ethernet header in the field ya Ethernet header. This field it contains the preamble, the frame start delimiter, the destination MAC address, the source MAC address pamoja na type. The preamble pamoja na frame start delimiter, they are not the actual part of the Ethernet header. Just stay tuned, nitakwenda kuelezea very soon why preamble and the frame start delimiter, they are not the part of the Ethernet header. The reason why nimeziweka hapa the preamble and the frame start delimiter is just for doing the discussion. So whenever you're doing discussion, you can include the preamble and frame start delimiter at the part of the Ethernet header. But the actual part of the Ethernet header, it really begin katika upande wa destination MAC address, the source MAC address, the type pamoja na Ethernet trailer. Also, we are going to see it very soon. Just stay tuned and worry out. Okay, now let me start explain what is preamble. A preamble is in a special sequence of bits ambazo zinakuwa transmitted kwa mara ya kwanza katika Ethernet frame before the actual data kuwa transmitted. And the main purpose ya preamble kuwa transmitted for the first time, zinatumika kuweza kumwambia a receiver ajiandae na kusynchronize muda wake kuweza kureceive hiyo frame. The problem is easy Ethernet device, they do not share the constant clock signal. So that's why there is a preamble, ambapo preamble inatumika sasa kuweza kumtaarifu a receiver ajiandae na asynchronize muda wake kuweza kupokea hiyo data ambayo itakuwa transmitted very soon. So whenever you hear the preamble means these are the special sequence of bits ambazo zinakuwa transmitted very earlier before the actual data kuwa transmitted. And the main purpose of this preamble zinatumika kuweza kumwambia a receiver to synchronize their time to be ready to receive the actual frame. Then The preamble, it is the 7-byte long, which is 10101010. You remember in the first layer of the OSI model, which is the physical layer. So the physical layer use these bits 101010 kuweza kutransfer hiyo data kutoka the source to the destination in terms of the electrical signal. Now think like this. Fikiria hivi preamble inapofanya kazi. The preamble inatumika kumwambia receiver, hey receiver, a data is coming, get ready and synchronize your clock. So the preamble inatumika kuweza kumwambia receiver ajiandae na kusynchronize muda wake. So these bits as you see, hizi bits unazoziona 101010 zitatumika na receiver kuweza kudetect the exact timing of the each bit, the voltage changes pamoja na transition of the interval. And that's all about the preamble. A start frame delimiter. A start frame delimiter ni next field baada ya preamble. So and hii start frame delimiter, it is 1 byte long, which is 10101011. Na ukiconvert katika hexadecimal you're going to get AB. Now ukiangalia vizuri katika the binary code ya start frame delimiter, bits mbili za mwisho zimebadilika. The preamble ilikuwa ni 10101010, but in the start frame delimiter zimekuwa ni 10101011. Now look here and be very careful. These bits zina maana yake. So the first bit of the preamble zilitumika kuweza kufanya synchronization, kumwambia receiver ajiandae aweze kusynchronize muda wake na kureceive data. Now the next field is the start frame delimiter. Now the start frame delimiter, it is going to send these bits 10101011. The last two bits zinatumika kuweza kumwambia a receiver kwamba hey receiver, the synchronization time has the completely, kwamba ule muda wa kufanya synchronization umeshaisha. Now the actual data inakuja baada ya mimi hapa, start after me now. So this bit, please be very careful. So whenever you hear katika start frame delimiter ina bit ngapi, it is long ni 1 byte, na biti mbili za mwisho zinatumika kumwambia a receiver kwamba synchronization time imeisha, so the actual frame is begin now. Destination MAC address. Destination MAC address, this is the real and actual part where the Ethernet header began. So the first part of the Ethernet header is the destination MAC address. The preamble and the start frame delimiter, they are not included as the part of the Ethernet header. The reason why the preamble and the start frame delimiter, they are not included as the part of the Ethernet header, the preamble used to synchronize the time to the receiver. The preamble used to tell and inform the receiver that they are supposed to synchronize their time and get ready to receive the incoming frame. It used the binary bits, which are 7 bytes. You remember, which are 10101010. So those binary bits zinatumika kwenda kumwambia receiver anatakiwa ajiandae na asynchronize muda wake kwa ajili ya kupokea the incoming frame. So you remember in the first video of the OSI model, the first layer of the OSI model, which is the physical layer. Now we say the physical layer of the OSI model used to convert the binary bits into electrical signal. Now the preamble used those binary bits, which are 10101010, which is 7 bytes. Now those binary bits, the electrical signal, they are going to be transmitted over the physical media of the first of the OSI model layer. So the preamble pamoja na start frame delimiter, all of those, they are using the bits. They are going to be transmitted katika first layer, the OSI model. So that's the reason why the preamble pamoja na start frame delimiter are not included as the part of the Ethernet header. However, many people used to confuse and mix and say kwamba the preamble pamoja na start frame delimiter zinakuwa included as the part of the Ethernet header. So keep it on mind kwamba the real part where Ethernet header inaanza ni katika destination MAC address. Okay, so now let us begin to the destination MAC address. The MAC address stands for the media access control. Do you remember in the IP address video? During the first session, I used to explain how the switch connects devices within the same local area network. I used to explain that MAC address, it is the 48 bits. MAC address ina urefu wa 48 bits which are being represented katika hexadecimal. And MAC address zinakuwa unique katika any network device globally. So for example, you're using your phone or your laptop or any network device or maybe a TV or whatever the case, hizo network devices zinakuwa zina MAC address, yani media access control, ambayo inakuwa built in kutoka from the manufacturer. So device inapokuwa inatengenezwa kutoka kiwandani inapewa MAC address ambayo haifanani na device nyingine yoyote ile globally. It is unique. And those MAC address, they are 48 bits long. Now, the important thing here is, unlike in the IP address katika upande wa routing, and you remember the IP address, these are the logical address. Now, here the MAC address is very important topic now, because the switch is care about the MAC address, and these are layer 2 switch. And remember, the switch inatumika to connect the device within the same local area network, but router used to connect different network. So the switch use MAC address. So for the switch ili iweze kutuma frame kutoka device moja kwenda device nyingine, basi lazima ijue MAC address ya source na pamoja na anayepokea hiyo frame. A source nikimaanisha kwamba a sender, lakini a receiver ndiyo destination. That is a targeted device. So the switch is supposed to know the source MAC address together with the destination MAC address ili iweze kutuma hiyo frame. Don't worry, I'm going to demonstrate very soon here katika Cisco Packet Tracer. We are going to see now how does the switch use to learn the MAC address and how it is decided to forward the frame from the sender to the receiver. The source MAC address. Also, this is the second part of the Ethernet header. The second field katika Ethernet header, it is the source MAC address. The source MAC address hii ni address ya sender device, but the destination MAC address ni MAC address ya device ambayo imekuwa targeted, I mean the receiver. And it doesn't matter ni source MAC address ama ni destination MAC address, zote ni 48 bits. So whenever you hear MAC address, it is 48 bit long. Now, as I said, kwamba hizi MAC address zinakuwa globally unique to any network device. Now, from the source MAC address now, this is the address that is going to be used by the switch to be added from the first time katika its MAC address table. So for the first time, maybe you have your laptop and you are trying to send a frame to your neighbor's laptop ambao umekuwa connected to the same switch. So what the switch is going to do now, for the first time, maybe you are trying to send the frame. So the frame inapo alive to the switch it is going to add your MAC address kwa sababu wewe PC yako ndiyo source. So your source MAC address inakuwa added to the MAC address table ya hiyo switch. Then the switch it is going to find or to map your destination MAC address kama hipo kwenye MAC address table yake. But don't worry also about this. Very soon I'm going to show you how this process happened. But what you are supposed to know is the first field is the MAC address, I mean the destination MAC address. The second field is the source MAC address. Okay, so here is the format of the MAC address. And MAC address, they are represented in terms of the hexadecimal. So MAC address, they are 48 bits long. Now, the first 24 bits of the MAC address, they do represent this is an organization Unicode identifier. The 24 bits is equivalent to 3 bytes. Once you convert the 24 bits into bytes, we are going to get the 3 bytes. So worry out about these 3 bytes. This is equivalent to 24 bits. Now, the first 3 bytes, so let's take this an example of this MAC address. So for this instance, I used to say the first 24 bits now, which is AA double colon BB double colon CC, this they use to represent the manufacturer ID. Then the rest, the last 24 bits, they use to represent the device ID. So DD double colon EE double colon FF. This is going to represent a specific device ID. So I use just this as an example to demonstrate how the format of the MAC address. But in the real world, you are going to see something like this is MAC address to your any device. So which means the first 3 bytes they represent the organization unique identifier ama manufacturer ID, while the remaining bytes they represent the 3 bytes they represent the device ID. So for example, kama unatumia maybe unatumia simu ya brandi ya Samsung, so maanake ni kwamba hiyo simu ina MAC address na the first 3 bytes kwenye hiyo simu zina represent that is manufacturer ID ambayo itakuwa ni MAC address ya Samsung, lakini bytes 3 zilizobakia zina represent the device ID ambayo ni simu yako, haifanani na device nyingine yoyote. So take a time and go and pursue and look to different phone of the Samsung and make sure umeenda kuangalia kwamba kwenye first 3 bytes zina represent organization manufacturer, so which means lazima zifanane, but the remaining bytes zinakuwa zinatofautiana. So take a time and go and pursue about this. So here are the types of the destination MAC address. There are different types of the destination MAC address that you're supposed to know. And kindly, we are going to use them as more as we continue learning about the CCNA, since we are in the topic of the switching. So these the broadcast, these types of the destination MAC address, you're going to see them and you're supposed to be familiar with them. So the first type of the destination MAC address is the broadcast address. I have already explained about the broadcast address, but when we're talking about the broadcast address means this is the address that is sent to all device, from one device to all device. So it is going to be flooded to all network devices that are in the same local area. And the destination MAC address, it is represented by FFF double colon 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 FFF double colon. These are 48 bits. So this broadcast address can be, for example, for the ARP message or DHCP discover. We are going to see how is the ARP process work. About the DHCP, we are going to see it in the next video. We are going to have the separate video of the DHCP. This is a dynamic host configuration protocol. This is a protocol that is used to assign IP address to the network device automatically. Worry out about this. We are going to have the separate video about DHCP. But know this, it is among the broadcast address ambayo inakuwa sent by the client. It is going to be broadcasted to all network device to find what is the DHCP server so as to request the IP address. But worry out for this video now. But for this video tutakwenda kufocus about the ARP, address resolution protocol. This is a protocol ambayo inakuwa send to all network device kuweza ku request ama ku map IP address to the specific MAC address. We are going to see very soon. And the next type is the unicast MAC address. A unicast MAC address, I have also already explained about the unicast MAC address. So unicast MAC address manake hii ni address ambayo inakuwa send to only single device. So for example, you are trying to send a message to me, or I'm trying to send a message to your phone. So the moment kwamba unanitumia mimi message, or I'm trying to send to you the message direct to you, that is a unicast address. So this address they are going to send to only single device. So for example, my MAC address is 00:11:22:33:44:55. This is represent the unicast address. Doesn't mean kwamba hii MAC address unayoona hapa ndiyo MAC address ya unicast address, kwamba ndiyo forever, hii ndio ndio standard. It change, it depend to the device. So for example, I use this maybe just for this lecture video, but it can differ, it depends to the network device. But about the broadcast MAC address, this is constant. This does not change. So whenever you see the destination FF, this is the type of the destination MAC address, which is the broadcast MAC address. This is constant. Remember this for your exam. But about this, you're not supposed to memorize this MAC address because this is just used here for the lecture video. But what you're supposed to know when a unicast MAC address is, a unicast MAC address ni address ambayo inakuwa send only to a single host. Then another type ya destination MAC address is multicast address. The multicast address ni MAC address ambayo inakuwa send from one device to a group, one to group. So for example, this multicast group can be the routing protocol such as the OSPF, eGRP update. Worry out about this OSPF and eGRP. These are the dynamic protocol. These, they are dynamic routing protocol. This they are going to advertise, they are going to tell each router they are going to advertise and share the neighbor's network information without you to go and manually and configure to any router. Worry out about this. Also, we are going to have a separate video tutakuwa tukielezea jinsi gani OSPF unavyoconfigure na kufanya kazi, how eGRP inafanya kazi. The next field is a type or length. It is the third field of the Ethernet header, but also it is 2 bytes long. Then this field, it is used to tell what is inside in the payload. Now, here are the different types of the field or different types of the packets ambazo zinakuwa contained katika the type or length field. Now, whenever you see 0x0800, represent this is IP version 4. So this means the payload, it contains the type of data which is IP version 4. But once you see 0x86DD represents the payload, it contains type of data which is IP version 6. Then whenever you see 0x0806 represents the payload, now it contains the ARP, which is address resolution protocol. Payload. Payload is a next field after the length or type. Now, the payload is the actual data that is being transmitted inside the Ethernet frame. The Ethernet itself, it does not understand any application data. So without having any payload in the Ethernet header, now the Ethernet header could not be able to transmit any application data because Ethernet by itself, it does not understand any application data. So now, the payload, this is the actual data that is being transmitted inside the Ethernet frame. So the Ethernet itself, as we say, does not understand any application data. So now, what is contained in the payload? There is different types of the data that can be contained in the payload. So for example, it can be the IP version 4 package or IP version 6 package or ARP message or VLAN traffic and other layer 3 protocol. So think just like the Ethernet is just like a container for transportation. But the payload now is the actual data that is being transmitted in that container. Let's take an example here. So for example, when you open your YouTube application, then the application layer, it generates and creates the HTTP request. Then finally to layer number 4, layer number 3, it adds the IP header. Then layer number 2, it adds the Ethernet header pamoja na frame check sequence. Now here is what it looks like. In the part of the payload, it will contain the IP packet, the TCP or UDP segment pamoja na application data. As I said before, the Ethernet itself does not understand any application data. So the Ethernet by itself does not transmit any data. But the payload now, the part in the Ethernet header which is responsible to carry and transmit the data. So remember this, the Ethernet is just like the container of the transportation. The data that is being transmitted in that container is your payload. Now, here is the minimum and maximum payload size. You remember the size of the length or type? The length or type field is 2 bytes. Now, the payload size, the minimum payload size is 46 bytes. And the maximum payload size is 1500 bytes. What is called, this is 1500 tunaita the maximum transmission unit. It is a standard Ethernet MTU, which is 1500. So once we preview from the first layer of the Ethernet header, ilikuwa ni destination MAC address which was the 6 bytes, ambao ukiconvert into bits unapata ni 48 bits. Then here the source MAC address is 6 bytes. This is the length or type field. Now this is the payload. As we said, the minimum payload size is 46 bytes. Now the 46 bytes, this is a minimum payload size, and the maximum payload size is 1500 bytes. Remember this. Then the next field, this is this is the frequency checksum. Padding refers to the addition of the extra byte to the Ethernet header so as to meet the minimum requirements. So let us take a simple example here. So for this example now, let us say the application layer, it has sent the data which is 20 bytes long. Now, once we preview or make the simple revision, tumesema kwamba the application data zinakuwa transported katika Ethernet header in the part of the payload. Now, and the payload, it has got the minimum frame requirement and the maximum payload requirement. The minimum payload requirement is 46 bytes and the maximum payload requirement is 1500 bytes. Now, for this instance now, our application imejaribu to generate data which is 20 byte long. Now, the 20 byte long, it does not meet the minimum payload size, which is 46 bytes. So let us make some simple addition here. So once we begin from the first field of the Ethernet header ambayo ni destination MAC address, it was 6 bytes. The next field, which is the source MAC address, na yenyewe ni 6 bytes. Then the next field is a length or type, na yenyewe ni 2 bytes. Now the next field here is a payload. Now do you remember the minimum payload size is 46 bytes, but for now it is 20 bytes, which means the 20 bytes does not meet the minimum payload size. Then the next field is the frame check sequence, which is 4 bytes. Now once we add these numbers together, we are going to get is 38 bytes. This is a frame. Once we add together these Ethernet fields kwa pamoja, tukiziadd hizi fields zote katika Ethernet header kwa pamoja tunapata the frame. Now, the frame, it has got its minimum requirement. The minimum requirement of the frame to be transmitted inatakiwa iwe na urefu wa urefu wa 64 bytes. But for now, it is 38 bytes long. What is going to happen? This frame is not going to be transmitted from the source to the destination device. Why? Because it has not met the minimum frame requirement. So once it is going to be transmitted, basi sababisha kuwa na collision domain. So the switch will not be transmit this frame from the source to the destination. The reason why, because haija meet the minimum frame requirement. Now the solution is a padding. A padding, as I said, in the addition of the extra byte to the Ethernet header so as to reach the minimum requirement. So now, the padding, this is going to be generated automatically with the Ethernet header katika part ya payload. So, Hapa mara ya kwanza application imejaribu kutengeneza data ikiwa na urefu wa 20 bytes. Now the padding itakwenda kuwa generated automatically with the Ethernet header kuweza kujazilishia hapa ili iweze kufika the minimum payload size. So now what is going to be added here to the payload so as to meet the minimum payload size? So how many bytes should be added here in the payload size so as to meet the minimum payload size? So now the bits that are going to be added katika payload size ili iweze katika payload ili iweze kufika the minimum payload size ni 26 bytes. So once we add the 20 bytes pamoja na 26 bytes tunapata 46. So the 46 bytes, this is a minimum payload size. So together tukicombine na hizi field nyingine katika Ethernet header, we are going to get the 64 bytes. So this is okay because the minimum frame size ni 64, lakini pia the minimum payload size it is 46 bytes. So this frame now is going to be transmitted from one device to another device because it has reached the minimum requirement of the frame to be transmitted from the source to another device. Kama device haijafika any minimum requirement, hiyo frame haitakuwa transmitted from any device. The switch is going to ignore that frame because it is going, kwa sababu itapelekea kutokea kuwa na collision domain. Don't worry, I'm going to show you how collision domain occur in the network. The frame check sequence. This is the last field of the Ethernet header. It is the 4 byte long. So this field is going to be used by the receiver side to check if there is any changes of the bits during the transmission. Now, I'm hoping you remember and you're familiar with the bits. The bits, these are the electrical signals that are being transmitted in the physical layer of the OSI model. Now, this electrical signal can sometimes be corrupted by the noise or the interference, damage of the cables, or collision, or the hardware problems. So that's why the receiver used the frame check sequence to detect if there is any bit changes during the transmission. Okay, so here is how the frame check sequence works. The Ethernet uses the cyclic redundancy check. Now, please be very careful here and listen to me. Now, in the part of the sender side now, the sender calculates the mathematical calculation from the Ethernet header then to the payload. So the senders used to calculate the mathematical checksum of the Ethernet header then to the payload. The result of calculation from the Ethernet header to the payload, now the results are going to be placed in the frame check sequence field, the Ethernet header. Now, the receiver is going to use the same cyclic redundancy calculation that was being used by the sender to calculate the checksum of the Ethernet frame, starting from the Ethernet header to the payload. Then the result was being placed into the frame check sequence field in the Ethernet header that the sender used to send. Now, do you remember I used to say that the receiver used the frame check sequence to see that frame if there is any errors? So now, how does the receiver use and view if there is any errors that are created from that frame? So it is going to use the cyclic redundancy calculation that was being done by the sender. So as you can see here, now the receiver is going to use the same calculation that was totally gated from the sender, ambayo ilikuwa ni cyclic redundancy calculation. Then if the calculation matches, now the frame is being accepted by the receiver. If the calculation does not match, now that frame is going to be discarded by the receiver. Remember this. Very simple. The Ethernet uses the cyclic redundancy checksum. Now, on the sender side, the senders use to calculate the mathematical checksum starting from the Ethernet header then to the payload. After getting the result is going to be placed in the frame check sequence field. Now, the receiver side is going to use the same cyclic redundancy calculation that was being done by the sender, then is going to cross-check. If the calculation matches, the frame is going to be accepted. But if the frame doesn't match, the frame is going to be discarded. Okay, so kwenye hii video nitaishia hapa and make sure una make follow up to the next video. because the next video it will be more practical. We are going to see how does the switch use to learn MAC address, how does the switch use to forward the frame from one device to another device, how does the switch use to store the MAC address to its MAC address table. So make sure una make follow up kwenye hiyo video nyingine, sababu itakuwa inaonyesha jinsi gani sasa hii Ethernet frame inakuwa learned katika switch na jinsi gani switch inafanya decision kuweza kuforward hiyo frame kutoka device moja kwenda device nyingine. And please don't forget to support me by subscribe my channel, share this video and comment. Thank you for watching my video.